Hello guys, this is CodeNCode and this is the ninth lecture of this dynamic programming series. And in this lecture we are going to see how subset sum problem is solved in linear space. In lecture 1 we have in the part 1 of subset sum lecture we have seen that this problem, given a array and a sum, we have to tell whether there exists a subset of this array such that its sum is equals to m exist or not. All we have to do is return true or false. But uh, in previous lecture, previous technique that we have seen requires n into m space, that is non-linear space. But this time we are going to see the technique in which you only need big of m space. So this is how we solved the problem previously. We were having a current space. The columns represent the sum, the rows represents the ith element, and then we simply fill and record effect of adding new element in the current set. And finally the final row would represent uh, uh, dp of n the number of elements in the array, and m the total sum. dp of nm is 1, then you can make the total sum m, otherwise not. So we were requiring n into m total space, but now we would only require big of m space, m the total sum. So here you can see I've taken a dp array of size 13 so that we have indices from 0 to 12. Now this is the current set. We would add one by one element from array to current set and see what is the effect of adding new element in the current set. Now you see dp of 0 is 1, the rest are 0. 1 indicates I can make this sum and 0 indicates we cannot. So currently if I have only an empty set, I cannot make a sum 12, but I can make sum 0, of course, because the sum of empty set is 0. That is just a definition or assumption. So if you have an empty set, of course by default you are having 0 sum. That is why the sum 0 is having value 1, because we can make a sum 0 using an empty set. Now let's insert or extend our current set with an element 2, which is the first element of the array. Now we would start from index 12. So can you make sum 12? To make sum 12 using this element, of course there must be a subarray already, there must be a subset already existing from the current set which is able to make sum 10. If using the current set, we won't look at the array at all, we would only talk about the current set. So if using the current set you are able to make subset sum 10, then you can make sum 12 as well, because all you have to do is take that subset which is making the total sum 10, insert 2 into it, and the total sum would become 12. But since using the current set we are not able to make sum 10, that hence we won't be able to make sum 12. Similarly for 11, to make sum 11 using the current element 2, there must be a subset using the current set such that its sum is equals to 9. But since there is no subset using the current set whose sum is equals to 9, that is why we won't be able to make sum 11 as well. We would keep checking this and until we reach 2. Now since using the current set we are able to make sum 0, what I can do, I can take that subset, insert 2 into it, and the total sum would become 2, right? So if you can make sum 0, then you can make sum 2, and this is all you can make using current set 2. So using current set 2, you can make sum 0 and sum 2, of course, because if you have this set, then you have two subsets, an empty set and 2. An empty set sums up to 0, and a set which contains element 2 sums up to 2. That is why these two elements are 1. Now we would extend our result by inserting another element, which is 5, which is the second element of the array. Now before going on, uh, why I started from n towards 0? Why didn't I started from m directly directly the current element, like I was extending the for example I am extending for 5, so why I didn't start from position 5 directly and go towards 12. So after extending current set by 2, that is after taking effect of 2, this is the resultant array, right? When we started from right towards left, try to implement the same from left to right. You would see there is a problem if you start from left to right. Suppose you are extending for say 2, right? Initially only 0 was set, so you would start from 2, because if you are going to use element 2, then you must start from at least 2. Reason, because if you are using element 2, then the minimum sum you can make is 2. You can't make sum 1 or 0. That is why you have to start from 2. So what you would do, you would see, okay, I can make some 2 if I can make some 0, but since we can make some 0, that is why you would mark 2 as 1. You would go to 3. You see, okay, I can make some 3 if I can make some 1, right? But you can't make some 1, so you won't be able to make 3. You would go to 4 now, and you will see, okay, I can make some 4 if I can make some 2. But since you can make some 2, you would mark 4 1 as well, but that is wrong. You cannot make some 4 using element 2 only. There's no way you can make some 4 using element 2 only without repetition. And when we are working with subset sum problem, repetition is not allowed. Ith element cannot be used more than once. That is why if you start from left to right, there would be a problem. That is why you have to start from right to left. Let's see what is the effect of inserting element 5. Again, we start from 12. I can make some 12 if there exists a subset whose sum is equal to 7. But since using the current subset, there is no subset whose sum is equals to 7. That is why we can't make some 12 as well. If you can't make some 7, then you can't make some 12, because you are going to use some current sum 5. So if you would use some 5, then to make some 12, you have already used 5. Now you want to make some 7. But since there is no way you can make some 7 using the current set, that is why you won't be able to make some 12. Similarly for 11, because you can't make some 6, that is why you can't make some 11. Till you would keep going towards left till you reach point 7. Now using the current set, there exists a subset whose sum is equals to 2, because at position 2 we are having 1. If you can make some 2, then you can make some 7, because you can take the subset whose sum is equals to 2, insert 5 into it, and the total sum is going to be 7. So that is why at index 7 I would insert 1. At index 7 we can't do anything, because there is no way you can make some 1. So we would continue. At position 5, since I can make some 0 using the current set, that is why I can make some 5. So at index 5 I would insert 1, and you don't have to go left, because current element is 5. So you can't make some 4 or lower using an element which is equal to 5. So using the first two elements, that is 2 and 5, these are the sum you would be able to make. You would be able to make 5 using only 5. You would be able to make 0 using empty set. You would be able to make 7 using 2 and 5. This is the only sum you can make. Now let's extend furthermore. For 3, again we would start from 12, but there's no way you can make 12 using 3 if you can't make 9, right, using the current subset. You would go to 11, same story. You would go to 10. You can make some 10, because you can make some 7 using the current set. That is why at position 10 we would insert 1. You would go to 9. Since you can't make some 6, then you can't make some 9. You would move on to 8. Since you can make some 5, that is why you can make some 8 as well. So at position 8 as well we would insert 1. So this is how this subset sum problem works. I can extend the whole. Okay, let's continue. For 5 we have done. Since 7 is already 1, so you don't have to do anything, just continue. You can make some 6 if you can make some 3. Since you can't make some 3, then you can't make some 6, so you would continue. You reach to 5, but 5 is already set, so you don't have to do anything. We will move on to 4. Can you make some 1? Since you can't make some 1, you can't make some 4 using 3. You'd go to 3. Since you can make some 0, that is why you can make some 3. That is why at position 3 as well you would insert 1. And finally you would stop for 3. So the current set is equals to 2, 5 and 3, and using the current set, these are the sum you can generate. You can make some 8 using 5 and 3. You can make some 10 using all of the elements. You can make some 5, of course, using the subset 5 only. You can make some 3 using 3. You can make some 2 and so on. So using the first 3 elements, these are the set. These are the sum you can make. So if someone asks using the first 3 element only, can you make some 11? The answer is no. Can you make some 10? Can you make some 10? The answer is yes. Looking at this array, you can tell whether the ith element, whether some x can be made or not. Now let's extend it to the fourth element and the final element. We would start from 12. Since you can make some 8, hence you can make some 12 as well. We'd move on to 11. Since we can make some 11, we can make since we can make some 7, we can make some 11 as well. So we would at position 11 we would mark 1. We'd go to 10, but 10 is already set, so we don't have to do anything. We'd go to 9. Since you can make some 5, you can make some 9 as well, so we would mark 1 here as well. We would go to 8, already set, so continue. We'd go to 7, already set, so continue. For 6, since you can make some 2, hence you can make some 6 as well. 5 is already set, so continue. 4, since you can make some 0, hence you can make some 4 as well. So finally we would mark 4 as 1 and we would stop. So using all of the elements of the array, these are the sum we can generate. You can see we can generate every single sum except 1. There's no way you can use some of the elements out of these and you can make some 1. There's no way. So now this was the algorithm. The question is how to implement it. So let's go for the implementation. So here's the implementation part. I've taken an array, integer array of size 100 only. You can take longer, doesn't matter. N and M. N represents the total number of elements in the array and input array, and M represents the total sum. So we have taken input N and M, and then finally reading all of the elements into the array. And we have taken a TP array of size M plus 1, initialize all of the elements with 0 except the 0th element, which we have to set as 1, because we know using an empty set we can make some 0. In fact, some 0 can be made using any array, because all you have to do is choose a empty subset. Starting from 1 to n, that is going for each of the elements one by one in the array. So starting from 1 to n, we would take the current element would be the ith element. Like we were going to extend our result for 4, so the current element was 4. So current element is the ith element, and then we would start from m, the last index, and then go till current element, decreasing one by one. So if the jth element is already set, that is if it is already 1, or if it is already set, then we don't have to do anything. That is why we would continue. For the second condition is this, is that if you want to make some, say, let me come just a second. If you want to make some 9, what you would do, you would go to and you are current element is 4. If you want to make some 9, you would go to 9 minus 4, which is 5, right? You would see whether at that index there is 1 or 0. So this is what you are doing here. You would go to index j minus current element and see whether it's 0 or not. If it is 0, then you can't make some j, right? So we would continue in that case as well. Otherwise the current sum, that is jth sum, can be made. That is why we would update it to be 1. This is all you have to do. And finally just print all of the elements from 0 to m. And then this is all the all algorithm. I mean, this is, as you can see, quite easy. And finally let's print the dp array. So this is the input, this is the total sum. So there are 4 elements, total sum is 12. Elements are 2, 5, 3 and 4. So you see, this is the output, final output. If you remember, final output from our slides representation looks like this. Every single element is 1 except the first element. So you see, this is how you solve the subset sum problem using only in linear space. So as you can see, the time complexity is still n cross m, while the space complexity we are able to reduce. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.